Okay, boys, this time round, plan of this lesson is that let's come up with what this shape is. Okay, so the key thing is here, let's have a look. We've got an x squared and a y squared. Okay, so if you think about my square root function, my square root function simply had a y equals the square root of x, which is almost like y squared is equal to x. My parabola has got y equals x squared. So in both of these, only one of them is really a squared term. In my circle, both are squared. Okay, so if you see an x squared and a y squared, this year, next year, it means a circle. Okay, and my general rule is there's my circle, okay, and that's my radius. So x squared plus y squared is equal to 1. Simply means it's a circle centered at the origin and it's got a radius of 1. So I think one of these shapes is a circle. Circle in here. So have a look how we go. May not be perfect. Oh. That's pretty good. Okay, sorry about that. So we've got our circle. Let's put some 1, 1, negative 1, 1. So let's think about what's the domain. The domain is those x values, isn't it? Oops, negative 1. So my domain clearly is from negative 1 to 1. My range is these values here, which again is going to be from negative 1 to 1. Okay, so key is x squared plus y squared. Tells me straight away it's a circle. Here, boys, if it's in this form, that gives me the shifting that's going to happen. So x minus h, a bit like our parabola again. That's a sort of x minus 1 all squared. It's shifting it to the right. Same thing happens to the y value this time. That's going to move it up. So it means the center of my circle will be at hk. Okay, so that's what we've got down here. The equation is my general equation. So the circle is at hk. Notice how the negative signs in there, moving in the positive direction of h and k, and the radius is r. So let's have a look here. All we need to know, oops, it's shifted. Let's change this color. I don't like that color. It's shifted 1 unit across, 2 units up. The radius is equal to, so it's equal to 4, which is equal to 2 squared. So the radius is equal to 2. So instead of mucking around with my device, my center is 1 across, 2 up. That's at the point 1, 2. The radius is 2, so maybe mark our radial, our endpoints in. So the radius is 2, so I go 2 down, 2 across, 2 up, 2 to the left. So we'll just, oops, it's a bad circle, guys. It's a terrible circle. Yeah, 4 back. So there's my circle. Now I can see I've got intercepts here. I touch there. I've worked it out by touching. So to work out my intercepts, y-intercepts, let's put x equal to 0. So if I put x equal to 0, I get 0 minus 1 all squared plus y minus 2 all squared equals 4. So I just get 1 plus y minus 2 all squared equals 4. Take the 1 across is equal to 3. square root both sides, plus or minus the square root of 3. So y is equal to 2 plus 3, plus or minus the square root of 3. So there's my two x-intercepts. Sorry, my two y-intercepts. So given that root 3 is somewhere between 1 and 2, isn't it? So it's 2 minus 1 and a bit, 2 plus 1 and a bit. So there's my 2 minus root 3, and up here is my 2 plus root 3, okay? If I want to do the same thing to get my x-intercept, I suspect what it's going to be. Put y equal to 0, so I get x minus 1 all squared plus 0 minus 2 all squared is equal to 4. 0x minus 1 all squared plus 4 equals 4. They cancel. X minus 1 all squared is equal to 0. X minus 1 is equal to 0 because the square root of 0 is 0. X is equal to 1. So we only get the 1 intercept there in this case, all right? But it's the same process, isn't it? You find x-intercept, you put y equal to 0. You find y-intercept, you put x equal to 0. All right, last example. Last examples, let's go back in there. All right, so again, look at that equation and you think, what the bloody hell is that? Big clue. It's got an x squared term, it's got a y squared term. So it must be a circle. All right. So what we do, first things first, let's group our x terms together. X squared minus 6x. Group our y terms together. And look, let's put it equal to 12. So we've got 2 x squared plus or minus, y squared plus or minus. Let's make them perfect squares. Got to go back to our completing the square knowledge, boys. So complete the square. X squared minus 6x. Half of negative 6 is negative 3 squared. We subtract that for equality. And then let's go to the y squared. Y squared plus 4y, it should be, Mr. Gale, plus half of that term squared minus half of that term squared for equality, and it's still equal to 12. There's my perfect square. X minus 3 all squared minus 9. Go to y now. Y plus 2 all squared plus 4 minus 4 equals 12. Take the negative 9 and negative 4 across. I'm going to get x minus 3 all squared plus y plus 2 all squared equals 25. So my circle has a centre at 3, negative 2, and has got a radius of 5. So what is the domain and range for this one? It's going to be much easier. It doesn't ask us, but let's do a quick sketch. Circle centered at 3, negative 2, which is there. And let's just mark in 5 from the key points. 5 across, x value. 5 across is at 8. 5 back is 3 minus 5 is negative 2. Think about the y value. Negative 2 plus 5 is up to 3. Negative 2 minus 5 down to negative 7. So I can do probably a badly sketched circle. That's not terrible. But let's concentrate on the domain and the range. So we've got the domain of those x values there. So let's go domain equals negative 2 to 8. My range is equal to, what's the value down here? Negative 7, wasn't it? Negative 7 up to 3. Okay, so that's probably as complicated as it gets, but again, don't forget domain, x value, range, y values. There's my set of x values there. There's my set of y values there. Just plot points, plot points. Okay, final graph to look at is our semicircle. And I guess there's the form of our semicircle here. And the key is again, how do we know that's a semicircle and not my square root graph? And again, the key difference is the square root function, just the square root of x. Here we've got the square root of x squared. So y equals the square root of x squared. So let's get a pen. If y equals the square root of x squared, if I square both sides, I get a y squared equals x squared. So there's that circular x and y squared are both squared again. All right. So the general, I guess in some ways, I think the easiest way is let's start here. If I square both sides, I end up with y squared is equal to 9 minus x squared, and that's the same as we go y squared plus x squared is equal to 9. So really, we can see that we're just looking at the positive, so the top half of my circle, and the circle, when I just rearrange it, is a circle centered at the origin with a radius of 3. So there's my circle. We'll call that 1, 2, 3. 1, 2, 3, 1, 2, 3. And because it was the top half, we just draw the top half of my circle. Okay, -3, +3, and 3 up there. So this time, the range of my function is just from 0 to 3, and you can clearly see the domain is from -3 to 3. So my domain, -3 to 3, range, which is the y values, from 0 to 3. Okay. Example B, what's the difference? Always, we've got a negative sign at the front. Exactly the same function, so we're going to be at -3, +3, but this time we're sketching the bottom half. So if we just do that, we've got this time the range. You can see it's the bottom half. So 0 to, oops, I was going to put 0 to -3, but we actually want to write the range is from lowest number to highest number. And my domain across here, clearly from -3 to 3. All right. So there's the full spectrum of graphs that you need to be able to analyze. Okay. So again, first few in here, try and knock them on the head, just sketching some basic circles centered at the origin. Then we move them a little bit left and right, and then make our way into a little bit of semicircle stuff. All right. So we've got five graphs or thereabouts, might be 4 graphs. One on x, one on x squared, y equals the square root of x, and x squared plus y squared equals r squared. They're the 4 key graphs. Okay. So get the question, righto, it's a y equals root x graph. So we just do a little sketch of a root x and then do the shifts that we need to. All right. If it's an x squared plus y squared, we know it's a circle. Find the center. All right. Have a go. Have a go, and we'll talk in class.